Understand the relationship between hybridization and bonding patterns. Carbon atoms form hybrid orbitals based on their steric number, the number of bonded atoms plus lone pairs surrounding the carbon sp to the power 3. Hybridization corresponds to a steric number of 4, tetrahedral local geometry, which occurs when a carbon atom forms 4 single sigma bonds. Sp to the power 2 hybridization corresponds to a steric number of 3, trigonal planar local geometry, which occurs when a carbon atom forms 3 sigma bonds, typically 2 single bonds and 1 double bond. Sp hybridization corresponds to a steric number of 2, linear local geometry, which occurs when a carbon atom forms 2 sigma bonds, typically 1 single bond and 1 triple bond, or 2 double bonds. Determine the Lewis structure and bonding of C2H2Cl2 dichloroethene to satisfy the octet rule for both carbon atoms. With this molecular formula, the 2 carbon atoms must be joined by a double bond, C = C. Each carbon is also single bonded to 1 hydrogen atom, CH, and 1 chlorine atom, CCl. Calculate the steric number for the carbons in C2H2Cl2. Each carbon atom is surrounded by 3 bonding domains. The C = C double bond counts as 1 domain, alongside the 2 single bonds, and has 0 lone pairs. Identify the hybridization. A steric number of 3 requires 3 hybrid orbitals, which are formed by mixing 1 s orbital and 2 p orbitals. This results in sp to the power 2 hybridization for both carbon atoms, making option D the correct answer. The correct answer is option D, C2H2Cl2.